Let's start the implementation of this problem. So first of all, we have to convert the number into digits. And we built an array that is ascending. Build the longest array that is ascending from button from end to beginning. After that, we check the length. If length okay, we go through the array from greatest to smallest. From smallest to greatest, and locate the first one that is greater than the out of order number. After we find that, we swap. We sort the array from smallest to greatest. And when we look at this problem, we always think of the natural sequence of the number. Okay? And then we check if the number is greater than int max. That's all the thing we need to do. So first of all, to convert the number into digits, we find the smallest. We started from the least significant digits. And we want to exit when n is 0. So we do this, and we find our first digits. And we update our n. We take a small test, 1, 2, 3. We push 3, we become 12. We push 2, we become 1. We push 1, we become 0. But the important thing is we want to restore its natural order. And we do that when we finish the first step. And now we go through the array from the back to its beginning. From back to beginning. That's from back to beginning. And we check every digit comparing to the one that is before it. And if it's before it, if the one before it is slower than it, is less than it, we stop. And we just find the length of the longest ascending order. And obviously we have to consider when we are approaching the end. Yeah. Yep, there's a better way to do it. We push back the last one. Because it's always there. I'm going to use this len a lot. We push back the last one. Yeah, and we check the second one from the last. And if this one is greater or equal to the one after it, it's qualified. That's beautiful. Now we check the lengths. If length, we know it's smallest as it could be. Okay. Okay. The length is okay, but we always want to return its natural order, and we push the first digit of the ascending array, descending array. Yeah, I should always refer to the natural order. And the descending array, the last number of the descending array is pushed to their last, pushed into the array last. So we have to reverse it. Yep, now the length is okay. Now we go from the first one is greater than our target. What's the index of our target? Okay. Because if we don't have a target, we will break, we will return. So target is definitely found. And now we go through from the back. Because there is always a number that is greater than target, so we will definitely find it. It's guaranteed. And we note that by compare is greater than what do? We swap. Do we break? we definitely break, otherwise we override it. Okay, now we sort the descending order. Now, and we write it to the digits. We want to do it backwards, so with our automatic stop. That doesn't matter. Now, digits, target, yep. This is self-explanatory. Should be a greater than 1. Okay. Perfect. Why? Yeah, implementation is hard. Yeah, this one is definitely hard at its implementation during interview. I should note that. That's right, target is right. New. Yeah, that's right. R, that's right. Come on. Concept and implementation, they're both difficult.